Alright, so this video we're going to look at present value for compound interest. And it says that the present value of $8 compounded at an interest rate I per period for n periods is P equals A over 1 plus I to the n. Or P equals A times 1 plus I to the negative n. You can use either formula to use it, it's the same thing. All this formula is this part moved up across the fraction bar. And remember, when you move something across the fraction bar, it just changes the sign of the exponent. That's why that's negative. All right, so let's see. R is the interest rate. M is the number of compounding periods per year. T is equal to the number of years. I is equal to R over M. And N is equal to R times, I'm sorry, that's not right. That should be M times T. Not a typo there. Alright, so M, the number of compounding periods per year. So what that means is if it's compounded annually, that means M would be 1. Semi-annually, M would be 2. Quarterly, M would be 4. Monthly, M would be 12. Daily, M would be 365. And then T is the number of years. Okay. All right. So now let's talk about what is present value. So let's say that in 5 years you want $10,000, and the money's going to earn interest at some rate. Okay, and it's going to be compounded either monthly, quarterly, semi-annually, annually, whatever. But what it is you want the $10,000 in like 5 years. So what present value does is it tells you how much do you need to deposit today in one lump sum. How much do you deposit today to get 10,000 in the 5 years at that interest rate compounded however it's set up. Okay, so that's what it is. It's one big deposit, and that's what it tells you. So here it says find the present value for the given future amounts. So we want $8,500 in 9 years, compound at 6% compounded annually. Okay, so how much do we have to deposit right now to have this amount in 9 years at 6% interest compounded annually? All right, so let's go ahead and let's come over here and write our formula down. So P is equal to A times 1 plus I to the negative n. All right. So first, well, let's just figure out what everything is. So we can see here that A is 8,500. R, our interest rate, is 6%, and we'll write that as a decimal, so that's 0.06. Compounded annually, so M is 1. And now we need to figure out I, which is R over M. So that's going to be 0.06 over 1, which is 0.06. And N is equal to M times T, which is 1 times 9, the 9 years. And that equals 9. All right, so now all we do, see, we have A, we have I, and we have N. So we just plug everything into our formula. All right, so we have P is equal to A, which is 8,500, times 1 plus I, which is 0.06, raised to the negative n, so raised to the negative 9. And so that's going to give us P equals, now there's a couple of ways you can do this. Plug it into your calculator. What I would do is, well, 1 plus 0.06, that's 1.06, and then raise that, So just type in 1.06 and then your exponent button, raised to the -9, and hit enter. And that should give you 0.591898464. And then just hit times 8,500 and hit equals. And that gives us 5,031 and round it to 2 decimals, and that's 14 cents. And there's your answer. All right, so let's take a look at the next one. So we have $17,230 at 4% compounded quarterly for 10 years. All right, so first let's write down our formula. P is equal to A times 1 plus I to the -n. All right, so A, well, that's 17,230. All right, R, the interest rate, that's 0.044%. M, compounded quarterly, so M equals 4. All right, I is equal to R over M, which is 0.04 over 4, which is 0.01. Okay. All right, and then N, that's M times T, which M is 4, so that's 4 times, and then T is 10, the 10 years. And so that equals 40. All right, so let's see what we get. Well, P is equal to A, which is 17,230 times 1 plus I is 0.01, raised to the -n, so raised to the -40. And so that gives us P is equal to, well, 1 plus 0.01 is 1.01, and then raise that to the -40, hit equals, and then times 17,230. And that is going to give us, let's see, $11,572.58. All right. All right, so let's take a look. I believe this is, yeah, this is the last problem. All right, so we have a zero coupon bond with face value $20,000 at 4.7% interest rate, compounded semi-annually, will mature in 15 years. What is a fair price to pay for the bond today? All right, so think of the bond as a 15-year investment paying 4.7% compounded semi-annually. Okay, compounded semi-annually, and its future value is the $20,000. So we're going to find the present value. How much do we have to put in there today at 4.7% interest for 15 years to have that $20,000 in the 15 years? All right. So that is going to be, well, P equals A times 1 plus I to the -n. And so we get A is equal to the $20,000. That's our future amount. R, that's the interest rate, 0.047. M, semi-annually, so M is 2. I is equal to R over M, so that's 0.047 over 2. And so 0.047 divided by 2 is going to give us 0.0235. And then N is M times T, which is 2 times the 15 years, which equals 30. So now, just plug everything in. We have P is equal to A, which is 20,000, times 1 plus I. I is 0.0235 raised to the negative n, so raised to the negative 30. So P would be, let's see, 1 plus 0.0235 is 1.0235. Raise that to the negative 30. Hit equals times the 20,000. And so that would be 9963.1. So that's $9,963.10. That's how much we would have to put in today to have this amount in 15 years at 4.7% compounded semi-annually. All right, so check out my other videos. Give me a subscribe. I hope this helped, and thanks for watching.